Now, you've got V. You have the power. And you want I. P equals I times V from page 2. Rearrange for I equals P divided by V. I equals 40 over 230. That then gives us, it's going to be a small number because it's current, 0.17. 1 mark for that, 1 mark for that. The lamps are dimmed at one dimmer switch set, the resistance of the dimmer switch is 82 ohms. The power loss in the dimmer is 118 watts. Use an equation from page 2 to calculate the current through the dimmer switch. Now we've got power, resistance, and we want current. We look at page 2, find a P, an R, and an I. P equals I squared R. Okay, we want the current, so we need to rearrange. P over R equals I squared. Stick the numbers in. 118 over 82 equals I squared. Equals 1.43. Now I is the root of 1.43. So I'm going to root answer, giving me 1.2 amps. Okay, calculate the power produced by each lamp at the dimmer switch setting. So this is where it gets slightly more complicated. So we know that the mains voltage is going to remain 230 volts. We want to know P. We need I. However, we know I splits in parallel. So if there's 1.2 amps there, each one of these bulbs, remember there's 12 of them, is going to have 1.2 divided by 12, which is 0.1 amps going through it. So there's 0.1 amps there, 0.1 amps, 0.1 amps, 0.1 amps. So I equals 0.1 amps. This is where this gets a lot more complicated, because you need to use the fact that the voltage is going to remain the same across each branch, unchanged. You want the power, and I, this time, we need to work back. This is in the series part of the circuit, so that's all of the current. Then it's going to split each time. So P equals I times V, Pi and V from page 2. P equals 0.1 times 230 equals 23 watts.